In this video, we're going to have a look at internal resistance calculations. So just to start with, it's asked you to define the EMF of a battery. So we know the voltage going through a component is the amount of energy going through that component divided by the charge going through that component. Now, the EMF itself is very similar, but instead of just the energy going through a component, we say it's the total electrical energy provided by the cell or battery per unit charge. So that's what you say for the definition, total electrical energy provided per unit charge. Moving on to, I just included this here at the bottom because we're going to go through this later, but this is actually the next part of the question. It says when the switch S is open, the voltmeter reads 8 volts. That means that because when the switch is open, the voltmeter only reads the voltage across the battery, which is the EMF, 8 volts. So that tells you the EMF is 8 volts. It then says when the switch is closed, the voltmeter reads 6 volts. So when the switch now is closed, the voltmeter no longer reads the voltage across the battery. It now reads the voltage across this resistor, which is parallel to, because current can now flow through that resistor now that the switch is closed. So that means that the voltage, or the terminal voltage, sorry, that reaches the rest of the circuit, except for the internal resistance, is 6 volts. Basically, the voltage through this component here is 6 volts. It then asks you to find the current when the switch is closed. Well, we can find the current through this component and say that's the current through the circuit because this component is in series with the whole circuit now. So current, I is V over R, so it's the voltage of 6 volts divided by the resistance of 2.4, and that's 2.5 amps. So let's write that out. Great. Moving on to the next part of the question, show that internal resistance is 0.8 ohms. So that's where we actually have to use the EMF equation, and I'd always recommend you use this for whenever you want to find internal resistance. So we can say that in the EMF, the total voltage through the battery is equal to the terminal voltage, the voltage that reaches everything except the internal resistance, that's 6 volts, plus current multiplied by internal resistance, that's 2.5, because that's also the current moving through the internal resistance, multiplied by little r, which we're trying to find. Subtract 6 from both sides, and we get 2.5 r is equal to 2. Divide both sides by 2.5, and we get the internal resistance is just 0.8 ohms. And that's the answer to part 2. Moving on to the next part of the question, it says the switch S remains closed. Calculate the power dissipated in the 2.4 ohm resistor. Well, when it's closed, we know the voltage through it. We also know the resistance through it. So the equation of power, which relates to V and R, if you have a look at your equation sheet, is P equals V squared over R. So here we're doing 6 squared divided by 2.4. And on your calculator, it will give you that that's just equal to 15 watts. Moving on to the total power dissipated in the circuit. Now that's talking about the total power dissipated by the internal resistor plus this resistor here, because they both dissipate power. The power is being supplied by the cell and it's being wasted due to the internal resistance and this component here. Let's find the power wasted due to the internal resistance. And let's do that in a different color pen actually. So we found the current through the circuit is 2.5 amps, and that's what flows through the internal resistance. Do we know anything else about internal resistance? Well, we know its value is 0.8 ohms now. Okay, how can we use current and resistance to find power? So power is actually equal to I squared R. So that's the current of 2.5 all squared multiplied by resistance, which is 0.8. That will give you a value of around 5 watts. And if you add that onto the power wasted due to this resistor, so we say PT for total power is 15 watts plus 5 watts, so that's equal to 20 watts. And that's the answer to part 2 of this question. It then asks for the energy wasted by the battery in 2 minutes. Now energy wasted is due to the internal resistance. So we now know the power that's wasted due to the internal resistance. We found that was 5 watts. And we also know the time that it's wasted for, which we have to convert into seconds by the way. So if we multiply the power that's wasted due to the internal resistance by the time in minutes, which is 120 seconds, because 2 times 60 is 120, that gets you to a value of 600 joules. Actually, does it? Yes, it does. Sorry, 600 joules. And that's the total amount of energy that's wasted. Hopefully everything here makes sense, and if you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video if it helped and subscribe. I'll post more content like this.